Hello everyone, welcome back. In this video, I will talk about the Spark notebooks, how you query your data using Spark notebooks, how you analyze your data using Spark notebooks, etc. And before walking you through the lab, I'll touch base on the key concepts that we hear when we talk about Spark. Now, and all this will be done using Azure Synapse Analytics. So if you haven't seen my previous videos or you don't know what Spark Analytics, what Synapse Analytics is, you can check the other videos in my channel and you'll get an idea about Azure Synapse Analytics and you'll know what I'm talking about. Now, before starting, let me introduce myself. I'm Sushil. I'm a certified cloud and DevOps expert. I have helped organizations implement their on-premises, their virtual, their cloud journey, and their DevOps journey. I have more than a decade of industry experience, and I'm passionate about fitness and technology, and I share my knowledge using my blog, thetechguy.in. Now, in this one, because I'm talking about Spark, I'm talking about notebooks and I'm talking about Spark, I want to touch base on the key concepts of Spark. Now, before starting, if you have not subscribed to my channel, I'd request you to subscribe because this video is part of DP-203, but I'm planning to cover the other Azure and AWS concepts also, and eventually the GCP also. So let's jump back. Now, what really is Spark? Spark was introduced or was developed by Apache, and Apache Spark is an open source engine which is used for the distributed data processing, and it is used for wide variety of functionality. It is used for processing, it is used for analyzing, it is used for manipulating, visualizing, it is used for almost everything that you can think of in a data lifecycle. Now, Spark is available as a processing option in many data platforms, which in Azure, you can use it with Azure HD Insights, you can use it with Databricks, you can use it with Synapse Analytics, and in this lab, we'll be touching base on the Synapse Analytics, and eventually in further videos, I'll touch base on HD Insight and Databricks also. Now, why do we really need Spark, or why should we really be using Spark? One of the benefit of using Spark is it supports a wide range of programming language. First of all, the languages can include Java, it can use Scala, it can use Python, SQL, R, etc. So it's really flexible. It gives you a lot of functionality of doing whatever you want to do with the data. It helps you because it supports so many things. You can use Spark for data cleansing, for manipulation, for analyzing, for machine learning, for visualization. So Spark really gives you a lot of methods to work on each and every phase of the data life cycle. And other benefit is it uses an in-memory cluster computing, which makes querying really fast. So Spark job can really load and cache data in memory. And as we all know, memory is obviously faster than disk-based applications. So since all this will be in memory, which means read and write just will happen from memory instead of reading from the disk, and it will be faster. So Spark, first of all, supports a wide variety or wide range of languages. It supports in-memory cluster computing, which makes it really faster. Now, what what is the usual Spark pool architecture? Not a lot of exams will ask you about Spark pool architecture, but I really thought it is something that we should know, or a good to have information. But if you don't want to know about Spark pool architecture, you can jump on the next section of the video. Now, Spark pool app architecture, there is something called Spark context. Everything in this is coordinated by Spark context, which is the main program called by the driver program. Now, driver program is responsible for managing your resources, managing your executor, managing your application. So Spark context runs in driver program, which eventually connects with the cluster manager, and then cluster manager allocates resources across the clusters, and on every cluster you'll have executors, every node you'll have executors, and then these executors take care of the applications that are running. Now, in the background, we'll have our file system, which is data lake store, and these executors will be running query, will be doing whatever it is designed to do, and then executors will send all the request outputs and data to the driver program. Now, what are the use cases in Spark Pool? As I mentioned, Spark Pool can be used for wide variety of applications. So you can really use Spark Pool for data engineering, data preparation, because here we can use almost, I mean, it can use a lot of languages. Now, since it supports Python, it supports R, it supports SQL, etc. We can really integrate it with machine learning, and we can train our models, because Apache Spark comes with the mlib library also, and we can use it for streaming data, for analyzing data. It can be integrated with Azure Function, it can be integrated with Azure Stream Analytics, HD Insights. So it really gives us a lot of use cases to be used with Spark. Now, one more thing that I want to talk about is the Spark database data abstraction APIs. Now, all this started with RDD, Resilient Distributed Dataset, which started when the Spark was introduced. Now, what RDD is, it is basically the fundamental building block in Spark. Now, when you think of RDD, you can just think of a collection of data like a giant list. It's not really an organized or structured data. It is just a distributed collection of data. Now, RDDs are really immutable, which means you cannot change data once it is created, right? So that is why what RDD is, and RDD can be processed in parallel across the cluster of computers. Then eventually Dataframe was introduced. In this lab, we'll be dealing with the data frames. I'll be talking about data frames. Now, data frame is one step above or one step on top of RDD. It gives you a high level of abstraction. Now, data frame, you can really think of think it organizes data in rows and columns, and which can be similar to a structured data or structured data that we have in database. Now, data in RDD, as I mentioned, it's a distributed collection of data, whereas data frame is a more structured way to represent data when compared to RDD. Now, you can really perform your SQL-like queries in data frames, which is in an added functionality, and that is why you would sometime prefer data frame on top of RDD. Then from the Spark 1.6, they introduced something called Dataset, which is one step ahead from data frame RDD. Dataset is essentially the middle ground between RDD and data frame. It combines best of both the RDD and data frame, which means it supports the strong typing. It enforces a specific type of data in each column, and it's suitable for the structured and semi-structured data. Now, when would you really use RDD, data frame, or dataset? Now, you would use RDD when you need the fine-grained control over the data processing and have unstructured data. You would use data frame if you have the structured data analysis and you want to use SQL-like queries. And you would use dataset if you want to balance between both the type. You want to balance between type safety and high-level operations. Now, next thing which I want to introduce is the magic commands. Now, when you are writing notebooks, there is something called magic commands that tells the notebook which language, because I told you, using notebooks, you can use, I mean, it supports a lot of languages. Now, how does it know which language you are really writing? So magic command is something that tells it which language are you going to use, or in which language you are going to write your queries. So when you write your notebook, on top you type your magic command, which tells it which type of query to expect. Person PySpark tells Python. This tells Scala. This is for SQL, C#, and Spark R. Now in our lab, we would be using PySpark and we would be using SQL for our lab. Now let me jump back in the video and let me show you the command, or let me show you the lab that I have created. Now this is the Synapse workspace that I've created. And if you don't know how to go to the Synapse workspace, you can go to, for example, in Azure, you have all the resources. I have all the resources. For example, I have this resource, and in this resource group, I have my Synapse Analytics workspace. In Synapse Analytics workspace, when you go to Synapse Analytics workspace, just like any other resource, there is a web space web URL, and this URL, if I click on this URL, it will take me to the Synapse Analytics web space URL now, which I've already opened. Now, this is the section where you deal with, where you really do what you want to do. And I will go to data. I've actually written all the queries which I'll be doing. Now, if you want to see the Spark notebook, Spark pool, you go to manage, you go to Apache Spark pool. This is where we go to Apache Spark pool. Under manage, we go to Apache Spark pool, and we have an Apache Spark pool that I've already created. Now you can really change your pause settings, you can change all the configuration, you can do a lot of things using the manage tab. But I can go to my, if I again want to write query, I'll go to develop, and in develop I can click on plus notebook. The other thing that we can do is, for example, I go to my data. If you see, I have a linked data lake storage. I go to my files, and I have my CSV stored in this location or in this folder in my storage account. Now I can right click on this. I can click on new notebook, and I can click on load to data frame option. Okay, now when I click on load to data frame, it gives you a structure that you can eventually query or eventually modify based on your requirement. That's what I've done. So this is the structure that it gave me. So right now what I'm doing is I'm using a magic command PySpark, which means I'm using Python. And then I'm telling it to create a data frame, and I'm loading from my location, which I already have in my location. The format is CSV, and I tell it to display my data frame, which is the data frame that I've written. Spark, I'm telling spark.read.load, which means I'm loading from this. The format is CSV, and I want to display my DF for the next, or the limit is only 10. I can click on play, and it runs the query. I can show output. My Spark, you see, it is saying starting Apache Spark session. I had actually started my Spark pool before this video, but I think it paused again because I waited for some time. Let me wait, because it will take some time. It takes 3-4 minutes before it starts the Spark pool, and then it will eventually return the query. So let me wait for this to start, and I'll be back. Now it is still starting. If you see, it says starting Apache Spark session. Now let me give you the background while it is starting. Let me tell you why we are seeing this. Now I told you can, so this section, this blade gives you, or lets you navigate to different options. Now I've talked about this in my Synapse Analytics introduction video. We can go to Apache Spark pools, and this is my Apache Spark pool, and I have a pause settings here to save the cost. We can disable it, which means it will not pause. But if I keep it idle for 15 minutes, my Spark pool goes to or pauses. And if you see there are active jobs, which means it is trying to start it because there is an active job, and that is why it is taking some time. It will take some time. Let's give it some time. Awesome. So it started. Now you see, it took 3 minutes 42 seconds, and Apache Spark session started in 3 minutes 16 seconds, and it took 25 seconds to run the query. And if you see, one thing I want to show you is the file in my Gen app or data lake Gen2 storage. We can click on preview, right? We can see what is the content of my file. I do not really have a header. Okay? I do not have a header. This is my entity. This is my query. This is the content of the file. So I did this. I did a right click on my file. I clicked on new notebook and I did load to data frame. And that is what gave me this query. And you see, there is no header. There is no schema defined as such. And I can click on this and I can hide output, or I can click on enable. I'll hide output because I've written next queries. Now, what I'm doing, I'm actually selecting just one file. Okay, and I'm specifying or I'm querying only one file. If you see, it took this much time. Now, if I run this query now, it will take a couple of seconds only because my Spark pool session is already started. And what I'm doing in the orders folder, I'm doing star.csv. So all the CSV in that file, in that folder, and I'm querying all the CSV. So it's the same query. I'm doing a load on this location. My format is CSV and I'm doing a display df limit 100. And this is what I'm doing. So all the files, it read all the files, and that is what it did. So you can really specify, or you can query all the files in a folder. You can query an individual file. You just tell it what format is, etc. Now, if you noticed, it doesn't have a schema, correct? It doesn't have a schema. So you don't really know what this means. So what we can do is we can define a schema. What you can do is you can use struct type to define a schema. Now again, I'm using PySpark, and what I'm doing is struct type. My struct field is sales order number, line number, etc. I'm creating a schema which is order schema. This is my schema that I'm creating using struct type. And now when I'm doing a load, I was already telling the format is CSV. Now I'm telling the schema is order schema. Now what is order schema? This is my order schema that I've created. Now if I run this, it's the same query, but you see, now I have a schema defined. Now compare it with this one. This is the same query, right? Spark read load orders star.csv format CSV. Spark read load format CSV, but here I have a schema. Now if you see here, I don't really have a schema. It populates a random C1, C2, C3 because there is no schema defined. Okay. Now why does that, why it happens? So that I define a schema in this, and that is what I did. So I have this thing done. Now next thing that now if you want to, I did this. Now if I want to just read this schema, see, this is my data frame. Now whatever I'm doing, whatever this query I'm doing, I'm loading it in a data frame. I'm naming the data frame as df. Okay, that is why I'm doing display df limit or whatever I'll be doing. I'll show you further. Whatever I'm doing, I'm running query against df. Df is my data frame, which I talked to you about. Now all this that I'm doing, I'm loading this in a data frame named df. That is what I'm doing. Now if I just want to see the schema, now what I can do is, it's an inbuilt function. Now what I do is df dot print schema to see my schema. Okay, and this is my schema. This is the schema that I created, sales order number, etc. This is the schema that I created. Now next thing what I can do is I can create new data frame using the existing data frame also. Now I can analyze data. Now I've created a data frame. Now data frame object, as you would have already understood, data frame object in Spark is basically similar to the Panda data frame in Python, and it includes wide range of functions, which one of it I showed you, the print schema, but there are a lot of other functions also. We can use count, we can use distinct. There are a lot of functions, inbuilt functions that are already available. Now what I'm doing, for example, there is customer name and there is email. There are two columns. Now what I'm doing is in DF, I just want customer name and email. Now a new code, now this will load customer name and email column from this existing DF data frame to a new data frame called customers. When we perform an operation on a data frame, the result is also a new data frame. In this case, the customer's data frame is created by selecting a specific subset of columns from the DF data frame. Now, data frames provide functions such as count and distinct that can be used to summarize and filter the data that they contain. That is what I'm doing. I'm doing a distinct and a count. Now, for example, I run this. See, first is count. I'm doing a count on customer. This is the customer data frame, and I'm doing a count on the customer data frame. Then I'm doing a distinct count on the customer data frame. And then I'm doing, here I was just doing the distinct count, and here I'm running or showing all the distinct values in my customer's data frame. Hope it is clear. In the customer, I loaded the value from the DF data frame. I just loaded customer name and email, customer name and email. That is why I just have a customer name and email. And I did a distinct on the customer's data frame, and I ran a display. Okay. Now next is, if you see, I can select a specific queries, and I want to group by also. Okay. Now let me run this. Now what I'm doing, let me show the output. Now when I'm doing, if I run this cell, you note the result show the sum of order quantities grouped by the product. Now group by method groups the rows by item, and the subsequent sum aggregates function, sum aggregate function is applied to all of the remaining numeric values in this column. It is the quantity. So what I'm doing is I'm running a select DF. If you remember, DF is my data frame. I'm doing a select on item and query. I am grouping by item, and then I'm running a sum, and then I'm displaying the product sales data frame. I hope it's clear what I'm doing. So you can really use all the inbuilt functions to manipulate the data in a way you want. Now the last one, see, right now till now I'm just displaying data. I'm not really analyzing the data. So for example, this one, now I can really group by the, let me hide the output, or so now right now we can also create views. If you have worked on databases, you know what view is. You can create views, and then you can eventually query those views. So right now what I'm doing is I'm creating a view called sales order. Now DF is my data frame. I'm using create or replace temp view function to create a view called sales order, and then I'm running my SQL query. Now one more thing. Okay. Now I'm doing this. Select star from sales order. Sales order is my view, and I'm loading this in a new data frame called Spark DF, and I'm just running this. So now if you understood now what this, what this query is doing now, though this code persists the data in the data frame as a temporary view named sales order. Now Spark SQL supports the use of temporary views or persisted tables as the source of SQL queries, and spark.sql method is then used to run the SQL query against the sales orders view, and result of the query is stored in a data frame. This is what we did. You should see, this is what I did. I just created a view called sales order, and it is now stored in spark underscore df. This is my temporary view. So you see, I'm just displaying this, and it is calling, it's selecting from my existing view that I'm creating, and the view is created from df. df was my existing data frame. Now I want to show you, because I told you about the magic commands. I can run SQL code also in a cell. Now it is useful to be able to embed SQL statements also in the cell, right? So we can use this magic command, and when I use person SQL, it knows I'm going to use SQL transact SQL TSQL queries, and I'm using a generic transact SQL queries. The SQL line at the beginning of the cell, as you already know, it's called a magic. It indicates that the Spark SQL language runtime should be used to run the code in this cell instead of the PySpark that we were using till now. Now SQL code references the sales order view that we just created using PySpark. If you remember, we created a sales order view. Now this references the sales order view that we were just created using PySpark, and the output from the SQL query is automatically displayed as a result under the cell. Okay, so what we are doing, we are doing select few items from my sales order, and then I'm grouping by year and ordering by the order year. This is a generic, this is a very normal uh, SQL transact SQL query that you might already know. But what I wanted to show is you can really work with PySpark SQL. You can embed this SQL queries when you're using PySpark, and then you can work on all of these in together. Now, other thing that I want to show is the last thing. We can also visualize. Till now, I'm just showing you the data. Let's visualize the data with the Spark also. Now, a picture obviously is worth 1,000 words, right? We can create a chart. The chart is often better than the thousand of words here, and the chart will really show you a lot of things. Now, while notebooks in Azure Synapse Analytics includes a built-in chart view, if you see the built-in chart view, um, it's not designed for comprehensive charting, but however, we can use this to visualize a lot of things. And then we can use a graphics library as Matplotlib and Seaborn to create charts from data in Dataframe, which I'll probably cover in next videos. But at least we can use the bare minimum, this chart option, to see the data that we have. For example, let me change it. Let me go to this, and let me keep the chart type as bar. Let me keep it as item, and values as, let's see, keep it as quantity. Series I'll keep blank, aggregation I'll keep sum, and stack is unlimited. And now if you see, I really have a very good visualized chart which tells me about the output, about the quantity based on the address that I was doing. I hope this video helped. I mean, in this video, I just wanted to tell you how you can really use Spark to query data that is existing on your data lake storage. Then you can export that in a data frame. Now, when you are exported into a data frame, then you don't really have to refer to the data. You can really use inbuilt functions to tweak, to transform the data that is loaded in the data frame. You can create a schema. You can create a view. You can export data from an existing data frame to a new data frame. You can group by, you can use existing functions. You can use the TSQL queries, and you can visualize also. And then probably if you want, let me know in comment section, and then I can show you how we can use matplotlib or the other graphic libraries to visualize this in a better view. I hope this video helped, and please let me know if you want me to cover anything else. And I hope these videos are helping. If it is helping, please subscribe. Thank you.